Hello, hello, it's Mr. Slope Guy here today with radicals and rational exponents. Radicals and rational exponents. And we've talked a little bit about exponent, 5 to the third being 125, or the cube root of 125 being 5. This 3 on the outside, that is the index or the root. 9 to the 1/2 power. Anything to the 1/2 is just asking for square root. That 2 being the root part, so we do the square root of 9, and the square root of 9 is 3. So b to the 1/nth, that n, the denominator, is the root. So 64 to the 1/3 is just asking for the cube root of 64, and we could probably do that one in our head. We can guess around with some 2's and 4's and come up with 4 times 4 times 4. Would be 64, or you could use your calculator to do a cube root of 64 is 4. All right, pause the video here and change each of these from having a fractional exponent to writing them in as a radical. All right, welcome back. So a to the 1/6 is the 6th root of a, and m to the 1/2 is the square root of m. And we can write that with the number 2, or square roots are so common we can just leave off the 2, and we know we're talking about square roots if there's no other number listed for the index. All right, you guys take these two that are given in radical form, pause the video here, and write them with a fraction for the exponent. All right, welcome back. We got b to the 1/5, and the square root of w is equal to w to the 1/2 power. What about negative exponents? Well, negative exponents will always make the inverse. So 49 to the 1/2 is going to make 1 over 49 to the positive 1/2. So making the exponent positive, following our law of negative exponents, is 49 to the positive 1/2 power. And then we can do 1/2 is the square root of 49. The square root of 49 is 7. So this reduces to 1/7. Then we have fractional exponents. So we know we've been practicing the y is the root. Well, the numerator, this x value, the numerator, if we have a fractional exponent, is the exponent inside the radicand. It's the exponent of the base of the radicand. So this numerator can be written on the x, or it can be written on the outside of the whole radical. Most of the time you see it here, but it's actually, either way, it's applying to the base of a. The denominator is always the root. The numerator is the exponent in the radicand. So we have the power of x. We have the y is the root. So, for example, if I have 32 to the 2/5, I would start with putting that 5 in the right place, put that in for the index, and then the 2 is the exponent in the radicand. So x to the 3/4 is the 4th root of x to the 3rd. And you're going to be given these to do forward and backwards, backwards and forwards, forward and backwards. So you're going to be given each one, and you need to be able to produce the equivalent. So a to the 6/5, always know that denominator is the root. So the denominator, 5th root of, and the numerator is, the 6 is the exponent in the radicand. So what if we're asked to evaluate, write an expression in exponential form? So this one, they gave us a radicand, and they want us to write it for a fractional exponent. Well, I have that square root here, and sometimes we write the 2, sometimes we leave that out. But I know that that is the denominator, and the 3, the exponent, is the numerator. So this is equivalent to 15 to the 3/2. The 6th root of 3, well, the 6th root part, the 6 is going to be the denominator, and the numerator is going to be the exponent from the radicand. So the exponent of the radicand is just 1. So I have 3 to the 1/6. The 4th root of a to the 7th, the 4 on the outside is the denominator, and the 7 is the numerator. All right, well, what do the harder problems look like? Well, let's say I have y to the 1/7 times y to the 4/7. When I multiply and have the same base, what do we do with the exponent? We add. Multiplying and have the same base, we're following our same rules for exponents. Multiplying the same base, we're going to add. So if I add 1/7 and 4/7, I get y to the 5/7. And I need to know that's equivalent to the 7th root of y to the 5th. So if I don't see this as an answer choice, I need to know that it's equivalent. Like knowing it's 0.5 and knowing it's 1/2, I need to be able to convert to and from either of those forms. Well, I have a negative exponent, x to the negative 2/3. I can make it positive 2/3 by dropping into the denominator. And if I want to put that in radical form, I know the denominator is the index and the numerator is the exponent. How about 3x to the negative 1/2? Making it a positive exponent, I drop it to the denominator. Anything to the 1/2 power is square root. So I get 1 over the square root of 3x. (15 to the 1/3 times 15 to the 1/3. If I'm multiplying and have the same base, what do I do with the exponent? I add. So 1/3 plus 1/3 has a common denominator of 3. So I can add my numerators and get 15 to the 2/3. And if I'm asked to put that in radical form, the denominator of 3 is the index and 2 is the exponent. How about 9 to the 2/3 times 9 to the 1/3? I'm multiplying with the same base. I add my exponent, 2/3 and 1/3, and get 3/3, and 3/3 is the same as 1. So 9 to the first power, or just plain good old number 9. All right, let's kick it up a notch. We have x to the 3/4 divided by x to the 1/8. And when I divide and have the same base, what do I do with the exponent? I subtract the exponent. So I have x to the 3/4 minus 1/8. Excuse me. Now, in order to subtract fractions, I need to have a common denominator. So I need to change that 3/4 to 6/8. Then I can subtract 6 minus 1 and get x to the 5/8. X to the 5/8 is the 8th root of x to the 5th. How about a power of a power, an exponent raised to an exponent? That is when you multiply exponents. Or I could do the square root of x to the 8th and get x to the 4th. Or I could do 8 times 1/2. 1/2 of 8 is still x to the 4th. Both ways simplify to x to the 4th. Excuse me, the 100,000 to the 1/5 is the 5th root of 100,000. And the 5th root of 100,000 is 10. All right, hope that gets you guys going on radicals and rational exponents. Have a great day. OUT spells